here's the system for the first of our two circuits. Okay, now this comes directly from what we did before. All I've done here is I've listed the currents in order of their numbers. Okay, 1, 2, 3, whereas before I had I3 minus I2 minus I1. So I've just rearranged that so that I1, I2, and I3 are in the same order. And I'm going to even do another thing. I'm going to change the signs of all of these, multiply through by -1. Just because that gives me a couple more positives. I'm not even sure that was a good idea, but I wanted to do it and it was easy. Okay, and I think I can do it without messing up. Okay, the second equation we had 10 volts minus 15 ohms times I1 minus 25 ohms times I2. Simply subtracted 10 volts from both sides and then changed all the signs, so I've got all positive signs here. Negative signs can be convenient, so it's not necessary to always do that. And then the third equation, we had, and you can see the remnants of it here, I1 times 10 ohms minus I1 times, you can't quite see that, it's 20 ohms. And you remember where that came from. You might want to look back at the circuit. I look at your notes because I hope you're writing notes as you do this to help you reinforce and focus on what you're doing. Okay, and keep yourself active so you're not just watching this passively. In any case, I just combine those. We have an I1 times 20 ohms and I1 times 10 ohms. I combine that into I1 times 30 ohms, and they're both negative, so that's negative. And then you can't see it over here, but we had a plus 15 ohms times I2, and that equals 0. Okay, so there's your system. Now, think for a minute, what would you do to solve this system? I'm not going to write and block the board at every step, but so I'm going to go off camera and write a couple of steps down here, but they're going to be fairly simple steps. How would you approach this? And then you compare that with how I approach it. You might have a better approach than I do, or one that works for you better. There are all kinds of ways to solve this system. Okay, I'm going to solve the system by elimination just because that's really convenient here. You can also set the system up as a matrix equation and grow, reduce, and augmented matrix, which is probably the most efficient way to solve a system. But we want to review what solving a system means. Might have been a while since you've had linear algebra, so I don't want to pull that out on you. Okay, so solving this equation, we're going to, put the add the 30 ohms times I1 to both sides, divide through by the unit ohm. We don't need that. We're going to end up with 15 I2 equals 30 I1, and dividing by 15 we get I2 equals 2 I1. In other words, this equation very quickly gives you I2 equals 2 I1, which allows us to eliminate I2 from these two equations. And then we'll have two equations in just two unknowns, I1 and I3. The first equation we get by substituting 2I1 for I2. So we get I1 plus 2I1, which is 3I1 minus our I3. And we have that equation. And then here, this equation doesn't get any simpler, but again, we will have eliminated we will have eliminated I2 from this equation, so we're going to have two equations here in two unknowns. So I2 equals 2 I1, so the 15 ohms times I2 becomes 30 ohms times I1. Then we have 25 ohms times I3 equals 10 volts. And now this is a system that we can solve for I1 and I3. We can solve this equation easily for I3. Let me just write it down in a different color up here. Actually, I'm going to do that off camera. There's no point in doing it on camera. It's very simple. So you go ahead and after you've paused, come back and I'll be writing out that part of the solution. Okay, this equation can be solved. I3 is going to equal 3I1. That should be really obvious. So that now we can take I3 equals 3I1, plug it in here. We're going to have 3I1 here. 3 times 25 is 75. So we're going to have 75 ohms times I1 plus 30 ohms times I1. 75 and 30 is 105. 105 ohms times I1 equals 10 volts. And just realized I'm off the screen. But what I just said should be pretty obvious. This is quite simple. We got 105 ohms times I1 equals 10 volts, so you should solve that. And of course you're going to get I1 equals 10 volts over 105 ohms. A volt divided by an ohm does give you an amp, so that I1 equals 10 volts over 105 ohms, which is 10 over 105, which is like 0.095 amps. Now we can back substitute to find I3, which will be 3 times that, 0.285 amps, and then we can find I2, which is double that. It's going to be 0.19 amps. Now that wasn't bad, but I went into some detail in the explanation, probably more detail than you need. We'll proceed with the other system with 6 equations and 6 unknowns. But just real quickly, I'm going to write out the augmented matrix that you would want to reduce in order to solve this system. So you should go ahead and do that yourself and then check with what I get in just a couple of seconds here. Okay, well, here's the augmented matrix. We have the coefficients of I1 here, here, and here. The coefficients being 1, 15 ohms, 30 ohms, negative 30 ohms. Coefficients of I2 here, here, and here. Those coefficients being, and I said 15 ohms here. Let's say it again. Okay, coefficient of I1 is 1, 0. There's no I1 in this equation. And then negative 30 ohms here. Coefficients of I2 are 1 and 15 ohms. There's our 15 ohms. And 15 ohms here. Okay, coefficients of I3 are negative 1 here, 25 ohms here, and no I3 here, so that's 0. And the right-hand sides are 0, 10 volts, 0, so we augment the matrix over here. And then we row reduce the matrix. I'm not going to go through the whole process, just to refresh your memory in case it needs to be refreshed. I can multiply any row of this matrix by anything I want or divide, and I can add 2 rows to replace either of the 2 rows being added. So, to make things a little more convenient, first thing I do is I divide both sides here by ohms. A volt divided by an ohm is an amp, so the ohms go away here. I get an amp here. So the numbers are the same, but I've got now 10 amps instead of 10 volts and no ohms on these. And of course here the ohms just divide out completely, leaving us these numbers. Now I make it even a little simpler. Now I divide by by simple numbers. I divide the second row by 5 to get 3, 5, and 2 amps. I divide the third row by 15, and I get negative 2, 1, and zeros here. Now I actually could have done even better with the second row. I did it down here. I'm going to go ahead and divide by the 3 because I know that I want a leading 1 in this row. If I remember how row reduction works, that's very obvious. So I went ahead and divided by the 3. I got 1, 5/3, 2/3 amp. Now, the other thing I did was I added double the first row to the third row. Double the 1 gives me a 2, added to negative 2 gives me 0. Double the 1 gives me a 3, add 1, I get 3. Double the negative 1 gives me a negative 2, added to 0 is negative 2, and of course doubling 0 is 0, which added to 0 gives me 0. Now I can continue. I can then add negative 1 times this row to this row. That'll give me a 0 here. It's going to give me a negative 8/3 here and a negative 2/3 amp over here. And I can add negative 3 times this row, subtract negative 3 times So that's the add. If I subtract, if I add -1 times this row to this row, I get what I said. Okay, if I add -3 times this row to this row, I'm going to take care of this 3. So I'm going to have zeros here and here. Remember, my goal is to get 1s on the diagonal and zeros every place else. And you see that at that point, I've made a whole lot of progress. And then we just continue the process in a way that you should be familiar with, and if you aren't, you need to refresh yourself. Not a difficult process, but of course you go a little bit nuts with all the fractions.